Hello. If you missed today's lesson, this is the lesson video recap. We're going to be doing some graphing today and looking at a model, a little story. But before we start, let's look at this question here. Which type of function do you think grows faster, quadratic or exponential? Take a second, make your guess based on everything you know about how they behave. Which one would you expect to grow faster? Well, we're going to answer that question by looking at a little story. You probably heard the fairy tale or fable of the tortoise and the hare. This is the math version of that. So we have the hare and we have the tortoise. There we go. And we'll go ahead and give him a little hat. I don't know why, but whenever I see a turtle, I always imagine him wearing a hat. So in the children's story, the hare basically is making fun of the tortoise that he's too slow. And so they challenge each other to a race. The distance from the starting line of the hare is given by the function d equals t squared, where d is the distance in meters and t is time in seconds. Now the equation for the way the tortoise is traveling is d equals 2 to the t. So just a quick recap, t squared tells us to multiply t by itself twice, where 2 to the t means multiply 2 by itself t times. So we will end up with different functions here, even though they look kind of similar in a way. So let's see what happens. So to help us with this problem, we're going to look at this little visual aid here. So we have the hare and the tortoise. Here's the race course. The starting line is right here. And we have our meter marks. And then over here, we have a table that is going to help us calculate how far each person has gone after each second. So to start off with, at time 0, when 0 seconds have passed, so this is the start of the race, the hare has gone 0 squared meters. 0 squared, 0 times 0, so that's 0 meters, obviously, right? So the hare is at the starting line. The tortoise has gone 2 to the 0 meters. So it's 2 to the 0 power, for those who don't know, that equals 1. We'll talk about that in a later lesson. The point is the tortoise is basically getting a 1 meter head start. So he is 1 meter ahead of the hare. Now, after 1 second, the hare is 1 squared, 1 times 1, which is going to be 1 meter. So the hare has moved ahead 1 meter. And the tortoise has gone 2 to the 1 meters. Well, 2 to the 1 is 2. And so that with the tortoise right there. So at this point, who's winning? Well, it appears the tortoise is still in the lead. He was given a head start. He's holding that head start so far. Let's see what happens after 2 seconds. So 2 seconds, the hare has gone 2 squared meters, which would be 4 meters. And the tortoise has gone 2 to the second, which is the same thing as 2 squared. So that's 4 meters as well. So what happens after 2 seconds? The hare and the tortoise are tied at 4 meters after 2 seconds. So, not looking good for the tortoise. Let's see what happens after 3 seconds. At 3 seconds, the hare has gone 3 squared meters, or 9. And the tortoise has gone 2 to the third meters, which is 2 times 2 times 2. 2 times itself 3 times. That is 8. So the tortoise has gone 8 meters, and the hare has gone 9 meters. So right now the hare is winning. And you can continue this table for more times and see what happens as time goes on. Does the tortoise end up winning the whole race? Does the hare end up winning the whole race? you can answer some of those questions. Another way we can look at this is with a graph. So you'll notice right here, this is basically a table of the same values that we have here. Just we made the calculator do all the work. You can type it in by hand, you can write the equations at the top, and it'll fill it in according to your t value over here. Lots of great stuff you can do. I also graphed the equations themselves for the tortoise and the hare. Probably should make the tortoise green just to match what we've done. Let's do that. There you go. And notice the points here, these are coming from the table. These tell us how far each animal has gone in a certain amount of time. So for example, we ended the table saying that after 3 seconds, the hare had gone 9 meters and the tortoise had gone 8. And you can see that on this chart at 3 meters, or sorry, after 3 seconds, the tortoise has gone 8 and the hare has gone 9 meters. That's what these points mean. So distance is being measured on the y-axis, or we should call it the d-axis, the vertical axis. The horizontal axis is measuring our time. And we can see which animal's in the lead by looking at who is on top and which animal is behind by looking at who is on bottom. So here the hare is losing because he hasn't gone as far as the tortoise. This point where they cross is where the hare starts to pass the tortoise. And it passes the tortoise, but then if you look over here, something happens at 4 seconds. The tortoise catches up to the hare and continues to beat him. Okay, so there's another thing this graph shows us, and that is the speed that the animals are traveling at. And that's kind of hard to see at first. To help you see it a little better, we're going to look at the table, and we're actually going to go here. So for those who don't remember, speed is the distance you traveled divided by the time it took you to travel. So if we look over here at the table, we can actually calculate the hare's speed for the first 2 seconds. He went 4 meters, and it took him 2 seconds to do that. So the hare's speed for the first 2 seconds was 4 meters in 2 seconds, which is basically 2 meters per second. Now that's not saying that he was traveling this exact speed the whole time, but if you were to average it out over those 2 seconds, he was traveling 2 meters per second since he went 4 meters in 2 seconds. The tortoise went 3 meters in the same 2 seconds, and so he's traveling at a speed of 3 meters every 2 seconds on average, which means that he is going an average of 1.5 meters per second. So that helps us see why the hare was able to catch up to the tortoise, because he was going faster. Not a whole lot faster, but slightly faster. Another neat thing you can see is that the speed that we're looking at for these animals is basically a rate of change. It's a slope. The change in the d value is represented by the rise, and the change in the t value is represented by the run. So if we go back to our graph, just as in the table we saw that he went 4 meters. The hare went 4 meters in 2 seconds. We can see on the graph that they went 4 meters in 2 seconds, and that gives us a slope of 2 meters per second. So we're basically looking at the slope of the line connecting those 2 points to say what the average speed of the hare was over that time. Now you can see he actually didn't go that speed the whole time. He went slower than that here, and then at about right here he's going 2 meters per second. Okay, and then he speeds up faster than that. Now this is a phenomenon that happens all the time, right? When you go on a trip in your car, you don't go from being 0 miles per hour, which is stopped, snapping up to 25 miles per hour right away. You have to accelerate up to that. So we're fluctuating speed the whole time. So this, the slope of these graphs is changing the whole time, implying that they're changing speed. But we can look at the average speed by connecting 2 points. So the average speed of the tortoise for the first second, they went 1 meter in 1 second. So on average, the tortoise was going 1 meter per second. Now their average for the second, they went 2 meters in 1 second. So that is a 2 meter per second speed on average. And if you look at the whole 2 seconds combined, they went, in 2 seconds, they went 3 meters. Okay? So they went 3 meters per 2 seconds, which is 1.5 meters per second, which makes sense because if you average 2 meters and 1 meter, you get 1.5 meters per second. So we split the difference because they're the same amount of time. So if you look here, we can actually look at how their speed is changing over time. So the the hare was speeding up 1 meter per second for the first second. Then the second, they increased their speed to 3 meters per second. Then they increased their speed to 5 meters per second. And then 7 meters per second. And the tortoise, on the other hand, went 1 meter per second on average for the first second. Then they increased their speed by 2 meters, so they're going 2 meters per second. Then they increased 4 meters. Then they increased 8 meters. So their speed is actually increasing with time differently than the hare's. The hare's speed is actually increasing 2 meters per second every second, where the tortoise's speed is increasing faster and faster as time goes on. So while the hare is speeding up at a constant rate, the tortoise is speeding up faster and faster as this race goes on. Okay, we see that in the graph by looking at the slope. The hare's slope is increasing, but it's increasing by the same amount each time. The tortoise's slope, on the other hand, just keeps getting steeper and steeper and steeper, faster and faster and faster. And if we zoom out, we can see that in the long run, the tortoise is going to be going way faster than the hare is. Now, one more thing to notice here. Which kind of functions are these? The hare, because the rate of change has a constant second difference, and it has a square value in the equation, we know that this is quadratic growth, whereas the tortoise, on the other hand, is actually exponential growth. The distance he's traveled is actually doubling every time, 1, 2, 4, 8, 16. So that is exponential growth with a constant ratio of 2. And we can see it here in the equation. You have the variable as an exponent. So now back to our original question, which growth grows faster? Well, exponential growth over the long run is going to greatly outpace quadratic growth. Although quadratic growth grows pretty quickly, exponential growth is going to grow even faster. So eventually it'll overtake it. The hare may win, it may go faster than the tortoise and pass it up, but in the long run, the tortoise is going to eventually overtake it and win the race.